Good morning and good evening, everyone. My name is Dr. Stojko Nikolic, and I'm the Technology Manager for the Hydromet and the Pyromet groups here at Glencore Technology. And I want to welcome you to our webinar today. Now, before we begin, I want to go through a couple of the rules. You would have been reading this up on your screen as you came into the lobby for the webinar, but just to highlight a couple of points, we do have this presentation today. There'll be a short one from myself going through the technology. I'll pass over to one of my colleagues, and then we're going to go to our panel discussion. So the panel discussion is going to go through all of the questions that you have from the first part of the actual presentation and webinar that we're doing today. So please, when we look at the questions that you may have, don't wait until the panel discussion occurs. Please jump in, ask your questions, because the first questions that are in will be the first questions that will be answered by the panel. So make sure you get those in quick, and then we'll be able to answer those questions for you here and now today. But don't worry, if it comes to all the other questions that come in, we're going to work through all of those and make sure that we can answer them and send that through to you before we look at sending on the actual presentation itself. So that's another important point, in that you will be receiving a recording of this presentation. And so therefore, if you miss anything, don't worry. If you get disconnected, don't worry. You'll be able to catch up on all of the information and all of this material so that you can get back to it at another point. Now, please ignore the raise hand button unless you have any urgent technical issues. That will be something that our team can then try and address with you going forward during this actual webinar. So what are we here to talk about today? What we're here to talk about is the recovery of the base metals through your oxide circuit. So just a bit of an overview before we begin. When you look at any oxide circuits or any mine that you have, normally they look at recovering all of the weathered oxide zones at the top of the ore body. You're able to get very high recovery of those base metals through the actual flow sheet or plant that you end up building for that purpose. But when you start going into transition zones where you start seeing this oxide sulphide mineralization, that's where you may take a hit on the recovery. And when you get into the primary sulphides of the D pit, or you go underground, if you stick to the same circuit or plant that you have, you will not be able to recover all of those base metals in your circuit. So really what today is about helping you maximize the recovery, move into that green zone section of that graph throughout all of the aspects of your ore. So we're really looking at the maximizing of your copper, your zinc, your nickel, and your cobalt through your process and through your flow sheet. So this will be presented by myself today and my colleague, Kel Roche, who'll go through a couple of flow sheet options. We're then going to be able to cross to our panel, where Paul, Rebecca, and Dan will be able to answer all of the questions that you have from today's presentation and any of the other questions you may have about our technology here at Glencore. So let's kick straight off. We're going to look at what happens in your primary, this weathered oxide region or the mineralized zone. Where do we start with most of our deposits? So here, obviously, you have the mine, you have the primary milling. What comes next in your flow sheet? Now, typically, this is where you look at extracting these base metals through a whole or a heap leach, depending on the grades that you may have. Now, after that, you're going to have your waste within the solids and your base metals within the liquid that you then want to separate through thickening and filtration, albeit in the various manners that can be done. So after this point, you then have a decision to make, and it really depends on the metal you're chasing, but also the quantities, also what you want to have as a downstream product. You can look at making a metal itself, so through solvent extraction and electrowinning. So for example, the copper process there, you can put through that process to make a copper metal. Now, alternatively, you can look at precipitating that base metal in a particular product to then allow it to go to a subsequent downstream process. But in that way, you then end up recovering your base metals as a final product as a final product itself, or as an intermediate product feeding into a downstream process. So when you look at normally what is the recovery that you're able to achieve through your oxide circuit as you put your metals and your ore through this flow sheet, in most operations you can typically achieve very high recoveries, all dependent on the amount of size reduction that you do for your ore before putting it in your heaps or whole ore leach circuits. Now, where we start to get into issues is if we move into these transition zones, where we start to move away from the oxides and move into the sulfide mineralization of your ore. Here, through the traditional flow sheet, you're not able to extract as much of those metals. You are going to start to see a hit in your recovery. So really, this is what we want to focus on. But before we get there, we should really talk about, well, why is it that you can't recover these base metals? And in this simple diagram that we have up here, our base metals are this blue mineralization that you see here. Why is it that we can't recover it? And that is if you put it through this acidic leaching process, what happens to these sulfides is that they start to form what is known as a passivation layer. So you're not actually able to put more acid to get in contact with the fresh base metal to be able to then extract it into solution. So then what are our options when it comes to this? What can we do when we hit these sulfides and to be able to still maintain our recovery? So the first step is to any mine when they look at the approaching sulfides is to look at, well, how can we take these sulfides out of our circuit and look at separating them? And so then we move away from this being a recovery through an oxide circuit, and we're going to be focused on the recovery of base metals through our circuit as a whole. So this is where normally in most locations they'll look at, okay, from primary milling, I now need to start forming a concentrate, put that through a concentrator, we'll send those sulfides out to sale to market, and then we'll take the tailings of that and put that through our existing flow sheet because there's still those oxides there in the mineralization and we want to be able to recover it. But putting it through this point of having a point of sale to a third party to treat this material, we're not going to be able to get the full recovery because we are then on selling this concentrate. We'll have to pay the treatment charges, refining charges, or even penalties associated with selling our concentrate. And we won't get the full value of the base metals from this concentrate material. Now, one thing you would have seen on that flow sheet was the concentrator, and we specifically labeled it as the Jameson Concentrator. So what is that? What is that all about? So we've taken the Jameson cell, which you see up in front of you on the screen now, which has hundreds of implementations in base metals. And what we've done lately is looked at full plant implementations of the Jameson cell. So this is an example here where you look at the full plant Jameson cell concentrator over on this side, which has within it quite a number of Jameson cells there. And we compare that against an equivalent tank cell flow sheet. You can see that what we are showing here is a huge reduction in terms of footprint, more than half a reduction there. And through that, you've got lower structural steel, you've got lower installation costs. It's a very, very compelling case for many sites. And please go to our YouTube channel or look out for the webinars that we have from our minerals processing team. And you can learn more about this Jameson cell concentrator flow sheet and the flow sheet options as applicable to you. But enough about the flotation plants. Let's bring ourselves back to what we're discussing today, which is recovery through your base metal circuit. So we've looked at, well, we're going to make a concentrate from this and we're going to sell that. So what is the next step? The next step is to then look at, well, what happens when we go into the primary sulfide mineralization? So what do we do there? We have our Jameson cell concentrator still in the flow sheet, but when we look at what happens there, we've run out of oxides. So if we've run out of oxides, we then end up making just a tailing stream from our Jameson concentrator. So that then makes the rest of our flow sheet for extracting metals in a way redundant if all we are doing is then selling that concentrate itself. Now, again, if this is the case, we're not able to recover any of the metal through an oxide stream. So we're going to be making even less of that revenue from the recovery of the base metals because we're selling more of the con. That revenue is going on to the third parties that we're selling that material to. So when we look at the next step, well, what are the other options that you have as a site when it comes to looking at this flow sheet, or even how can we look at utilizing the existing capacity, all that material, all those equipment that we grayed out and removed in this flow sheet? How is it that we can actually access that? But before we get to that, we have to address how are we going to overcome this passivation process, or the inherent chemical nature of our actual material that we're putting through our process. So today we're going to look at how we do that with the Albion process, because this is something that is very different to the other options out there. So with the Albion process, we have our material that comes in, let's say coarse 70 micron con. We want to be able to access that. And how do we look at of overcoming this passivation layer? We do that through size reduction. So we're going to make it finer. We're going to be able to access this material so that we can then leach it through our oxidative leaching process. So we do that through our ultrafine grinding mill technology, the IsaMill, and that allows us to be able to access these base metals within our oxidative leaching circuit. So it's all done at atmospheric pressure, so no high costs in terms of pressure. There's no complications in terms of chlorides or in terms of bacteria or anything like that. We're just taking this as a simple approach, size reduction, oxidative leaching. So how does this influence your flow sheet? We then go from our concentrator through to our IsaMill, which is then doing our size reduction. That then goes to our Albion oxidative leach reactors, which is where we then take those base metals into solution. Now, this is where we take into account the use of your existing infrastructure or the infrastructure that you want to build for your oxide circuit up front, thickening and filtration, and then we're going to be able to use the particular flow sheet that you had of your choice in the beginning to make those base metals. So what that allows us to then do is be able to recover all the value of those base metals within our own flow sheet, within our own operation, and then allows us to operate in this region in the green where we want to, independent of where we are within the ore body itself. And this is really one of the powerful things. But one of the first questions you'll ask me is, well, what do the results look like for a plant of this type in terms of the Albion process? What I've shown up here is an example from one of our copper Albion plants. So this was one that was commissioned in Zambia. You can see this is the start of the commissioning period in 2017, and you can see the results as we move through into 2018 and beyond. And so this here, this recovery that we see here is in the 97, 98+%. Bordering on an average of 98.5% during this period of operation, where you can see the Albion process was able to then make the final metal product for this plant, reutilizing all of their existing infrastructure to be able to do that and then make this operation viable and profitable again. So where is all this done within the Albion process itself? We've got a number of operations around the world in base metals, so 4 of them. We've got 1 in copper and 3 in zinc and lead. But when you look at the other parts of what we discussed, the Jameson cell technology, that in terms of floating these base metal cons, we've got over 100 of them around the world in IsaMills for treating these base metal concentrates, well over 100 of those. And in terms of our other aspects of the Albion technology, we've got many of those as examples in the installation in the real world. So at this point, I'm going to hand over to my colleague, Kel Roche, who's going to be able to take you through some of the case studies of applying the Albion process for these aspects to existing sites. Thank you.
Thanks, Dago. Hi guys, my name is Glencore Technology, one of the hydromets here. I'm reporting to Stanko, so come talk to me and the team about any of these questions that you have. Just a reminder, please get your questions in now so the panelists can answer them. Apologies, guys. It helps if you turn the microphone on. Hopefully you can hear me better now. Try again. Kelvin Roach in the Hydromet team. Right, business case for Albion. Why would you build an Albion plant and run an Albion plant as opposed to just selling your concentrate? So, big one, it unlocks a feed that cannot be tested through conventional flow sheets. This is material that can be not floatable at all, has penalty elements in it. It has uneconomical float conditions, as you need too much suppressant, for example, if you have high talc. Big part of Albion is it doesn't need to be concentrated at all. You can feed an Albion plant with just ore. You can feed it with slimes from a refinery. You can treat it ESP dust from a smelter, for example. So please don't think it's just concentrate, but the big positive of Albion is it can treat things that aren't conventionally floatable. It also allows treatment of conventional low-grade or middling concentrates, so that you don't have to send a final con. It's actually preferable in a lot of ways to send a rougher con because of the higher sulfur grade. And that, as Stanko mentioned, it means you can focus more on recovery in your float circuit rather than trying to get that grade up. There is a convenient little graph here that we prepared earlier. You'll see that usually your grade would fall away as you try and push that recovery. That is not an issue if you're using the Albion, as we can then get that maximize the recovery in the float circuit and get that metal out in an economical way. And obviously that will improve your bottom line of the flow sheet and of the project. Next one there is you operate the float plant in high recovery. I literally just jumped ahead and talked about that one already. And then the solution for contaminated concentrates. As I said earlier, a lot of these cons, if you sell them, they'll have a penalty product in them. You may be charged a penalty rate for that, or you won't get paid for those contaminants. In Albion, you can extract them as a separate stream into a saleable product. Therefore, for example, if you've got a gold, you may not have a sufficient gold grade to get gold or silver credits, but if with Albion, you can extract them as a separate stream. If you have, I'll get to that. I'll get distracted here. Going the wrong way again. All right, so we have 3 flow sheets here. These are just fairly generic flow sheets, a sort of a base case, intermediate, and a more complicated flow sheet. They're just examples that we've pulled out. There is many, many potential flow sheets, as Albion is so incredibly flexible. It can be tailored for nearly any oxidizable metal and any oxidizable feed that has sulfur. So these are just examples. For this case, we've used, this is a copper, gold, silver, very standard. We've used a concentrate. Again, we could just use an ore. We could use anything else, but for this case, we have used a concentrate. Goes through our IsaMill, as Stanko said, to get it down to an ultrafine grind. Goes into an oxidative leach. That is your Albion process with the HyperSparge technology to oxidize that metal. Goes to a neutralization step using limestone. That's to prep your slurry or your solution to what comes next. So that's to prep it for whatever your downstream process is, preferably a pre-existing piece of equipment, as Stanko mentioned. Goes through a solid liquid step, thickener, filter press, what have you. Ideally, it's something that's already pre-existing. In this case, we're going to an SXEW and producing a copper cathode. There's also a separate stream here where we are floating the precious metals out. And again, that's metals that you wouldn't normally be able to recover if you were just selling your concentrate. There's a couple of notes there. In terms of economics, about 10,000 tonnes per annum is where we usually start in terms of economically attractive projects. Anything below that, not quite economical usually, but anything bigger than that, the sky's the limit. The big benefit of Albion is it is very modular. So you can start small and you can ramp up as the project develops and as capital becomes available. We've already mentioned the grade does not really impact the process. So please don't think that those numbers that Stanko was throwing out earlier are sort of too high for my project. Grade is not really a big issue in terms of being able to economically extract that metal. We've already mentioned that. So moving on. Again, I'm going backwards. So copper zinc, very standard flow sheet here. Again, you'll see the front half stays exactly the same. And this is a big advantage of Albion. We can keep that same front and change the back if you change feeds, if you change ore bodies. It keeps that modularity about it. So in this case, it all stays exactly the same. going to a copper cathode, you've still got your precious metal. But now, in this case, we've got a bleed stream that is getting your nuisance level of zinc as a saleable precipitate, in this case, a zinc con. So rather than being charged a penalty for having zinc in nuisance levels in your concentrate, you're now making that as a saleable product. Third one, a bit more interesting, this one. This is a copper cobalt. It could easily be a copper nickel or copper moly or anything of that nature, but in this case, it's copper cobalt. You'll see that the front half, again, stays exactly the same. That way, you're maintaining all that capital, you're maintaining all that equipment, and you're just changing the back half, tailoring it for a different feed or a different stage of the project. In this case, you'll see it all stays exactly the same, but we are precipitating a cobalt product. So I think, yeah, we are out of time for me, unfortunately.